Hello there. Welcome to video number 2 for systems of equations. This particular question is it's kind of like a break-even question, very similar to what we did in the last video. And as I go through it, please remember that the expectation is that you solve these problems using systems of equations. Like I said, I know you could probably figure them out other ways, but the point is for you to apply uh, the knowledge that we're learning in class to solve these questions, and that's what I'll be testing you and checking you on, because our knowledge is a little bit limited still to in some of the applications. So keep that in mind. In this question, there is a local zoo that's filling 2 water tanks, and one of the water tanks contains 50 gallons of water, and it's filled at a constant rate of 10 gallons per hour. Now, one thing I suggest you do whenever you can in these problems is sketch a picture. Now this picture is showing what they're telling me here. All right, they said that in this tank they already have 50 gallons of water. Okay, it's an elephant tank. And then, so let's call that tank number 1. And then over here there is a second water tank, and it only contains 29 gallons of water. So here's tank number 2, and it contains a little bit less water. It contains, I'll say, 29 gallons. Okay, now let's go back to the second sentence here. One of the tanks that contains 50 gallons of water is filled at a constant rate of 10 gallons per hour. So they are filling this up at a rate of 10 gallons per hour. And they're going to fill this tank up at a rate of 3 gallons per hour. Okay, it says when, at what time, or how much time will pass until the 2 tanks have the same amount of water. So what we need to do here is we need to have variables that represent the information we need to solve this problem. So I'm going to let x represent the number of hours that the tank is filling. And I'm going to let y represent the number of gallons in the tank. And you may be saying, well, we already know how many gallons are in the tank. Yes, we do, but once we start filling it, that amount will increase. It'll be changing constantly. So for tank 1, all right, I'll call this tank 1, we can write this equation. We can write the equation that y, which represents the amount of water in the tank, is equal to 10 times the number of hours they've been filling it, because it's 10 gallons per hour, okay, plus 50. And then tank 2, all right, right here, we will say tank 2, the number of gallons in tank 2 is equal to 3 times the number of hours the tank is filling, plus 29, because it starts with 29 gallons. Okay, so to solve this question, I'm going to slide down just a little bit. Needs a little bit more space here. What we want to do is, kind of like we did break-even point, we want to set these 2 equations equal. So we're going to substitute again. We're going to substitute that equation in for that y, because y is isolated right there. We want to know when are the number of gallons equal. All right, so I'm going to say that 10x, because that's tank 1, I want to know when does tank 1 equal tank 2. So tank 1 is 10x plus 50. That is equal to 3x plus 29. All right, well, let's solve this equation. We can do it either way here. I think what I'll do is I will subtract this 50 here, and I have 10x is equal to, I'll be subtracting 50 from there now, 3x, okay, 29 plus 50 comes out to be, I believe that's negative 21. All right, now I'm going to subtract 3x here. I want to isolate the x, just like we've learned. And I have 7x equals negative 21. Go down a little bit farther here. Okay, let's go ahead and solve that. Divide that by 7. And look what happens. We get x is equal to negative 3. All right, if x is negative 3, now we could go ahead and substitute that back in there and solve, but something should be going off in our head that something is not right here. Well, if we substitute, let's go ahead and substitute it back. What the heck? Uh, I'll substitute it into 10x there. So if I said y is equal to 10 times negative 3 plus 50, we get y is equal to negative 30 plus 50. We get y is equal to 20. All right, so I get negative 3 for x and y is 20. Let's go back to our variables here. X is representing the hours that the tank is filling. So we came up with they're the same at negative 3 hours. Okay, now what in the world is going on here? What this means, do you know what this means? This means at no time will these tanks ever be filled. Okay, so the answer is there is no solution here because there's no such thing as negative 3 hours. Now we can say 3 hours ago, but that's not relative to here. We can't go back in time, or this problem is not about that. So there's no solution here, but this is the proof that there is no solution because you can't have negative 3 hours. So the point of this problem, okay, and the point of, if you noticed here, identifying constraints and viable solutions, well, you do have to interpret your solution and say, does this make any sense, and is this even possible? And this one is not possible for us at all. So it's no solution, and I'm thinking some of you might have seen that at the very beginning, because if you notice, this has more water and it's rising faster. This has less water and it's actually rising slower, so it'll never catch up. But we proved it here mathematically that it is indeed impossible to answer this question. So there's a solution to number 2, and we will stop this and restart the video for wind and current problems, which are always entertaining, and we'll be right back for that.